On Alice's 11th birthday, she started to receive an annual allowance. The first annual allowance was £500, and on each following birthday the allowance was increased by £200. So, when she was 11, she got £500. When she was 12, that would have gone up to 700. 13, it's gone up to 900. 14, 1,100, and so on. So what we have here is a arithmetic sequence, where our first term is 500, our second term is 700, our third term is 900, our fourth term is 1,100, and so on. Our first term is 500, the common difference is 200. Right, part A. Show that immediately after her 12th birthday, the total of the allowances that Alice had received was 1,200. Well, on her 11th birthday, it was 500. Her 12th birthday, it was 700. So the total is 500 plus 700, which is 1,200. Part B. Find the amount of Alice's annual allowance on her 18th birthday. So when she was 18, that's the 8th number in our sequence. I can tell that just by looking at 11th birthday is 1, the 12th birthday is 2, the 13th birthday was the third number, and so on. So the 18th birthday would have been the 8th number in this sequence. So I can use the nth term formula from an arithmetic sequence, which is a plus n minus 1d. A, in this case, is 500 plus 8 minus 1 times 200, which gives me £1,900. Part C. Find the total of the allowances that Alice had received up to and including her 18th birthday. I can use the sum formula for this. The sum is equal to n over 2 times 2a plus n minus 1d. Remember that n on her 18th birthday is 8. We know that a is 500. And we know that d is 200. So working through that calculation, I can find that she earned a total of £9,600 in those years. When the total of the allowances that Alice had received reached 32,000, the allowance stopped. Find how old Alice was when she received her last allowance. So the total of the allowances. So again, I'm thinking about the sum formula. So let me just copy that down again. Sn equals n over 2 plus n minus 1d. So when did the sum equal 32,000? So n is what I'm trying to find out here. I know that the a is still 500 and the d is still 200. So basically I want to try and solve this equation to work out what n is. So let me tidy up the inside of those brackets there. So I've got 1,000 plus 200n minus 200. The 1,000 minus 200 is just going to be 800. And I can now multiply through by n over 2, or half n. So 800 times n over 2 is 400n. N over 2 times 200n would be 100n squared. I can now divide through by 100, and I'll get 320 equals 4n plus n squared, or n squared plus 4n minus 320 equals 0. I now want to solve this equation to work out what n is going to be. So I'm going to use the quadratic formula to do this quickly. You've obviously got your quadratic solver on your calculator to help you with this as well. So I find that n is 16, or n is going to be minus 20, which is obviously not going to be a suitable answer to this question. So n is 16, the 16th number in this sequence. So the 16th number would be when she was 26 years old. So 26 years is the answer to part D.